A very good afternoon to all present here. In today's class, I'm going to discuss about the cantilever beam, in which we are going to solve the shear force bending moment values as well as the to draw the shear force diagram as well as bending moment diagram concepts. First of all, we should know what is a cantilever beam. A beam which is one end is fixed, another end is free. That is called a cantilever beam. Here the thing is given as having a cantilever beam in which one end is fixed and another one is a free end. And the free end we are having 2 point loads of values 2 kilonewton and 1.5 kilonewton, which are acting at the point C as well as B respectively. The total span of the beam is 1.5 meter, and the values of 2 kilonewton acting at point C, which is from 0.5 meter from the point B, that means for the right support. So this is the problem given to solve for the shear force and bending moment values as well as the to draw the shear force diagram and the bending moment diagram. First, what should we do? First thing is we have to start with the to find the support reaction. How to find the support reaction? Here we are having a fixed support in which we are having three support reactions are there. One is vertical, then another is horizontal, the third one is translational, that is moment. Since there is no horizontal forces, so we need not to find the horizontal reaction as well as there is no moment, external moment is applied. Only the point load which are vertical loads are applied here. So we have to put place a vertical reaction at a point, that is RA. So to find RA, we have to use the statically equilibrium equations. The statically equilibrium equations are: one is sum of all vertical forces, that is equal to 0, as well as all horizontal forces are equal to 0. And another thing is called based on the moment, the sum of all moment, bending moment about any arbitrary point, that is equal to 0. Since we are here, we are going to find the support reaction, that is the load. We are going to use the support reaction, that is the sum of all vertical forces, that is equal to 0, that is sigma Fy, that is equal to 0. For this we have to have a sign convention. One is upward and one is downward, that's all. So you just have a sign convention, which one is positive, which one is negative. So here I'm taking towards upward forces. Here we are having upward force here and downward force. These two are downward forces. So I'm taking these two are negative and this one is positive. So RA, which is equal to 2 plus 1.5, that is 3.5 kilonewton. That's the thing is given. RA, this is minus 2, this is minus 1.5, that is equal to 0. So finally I am getting the support reaction at point A, that is equal to 3.5 kilonewton. The first step is over. Next step is to find the bending moment or shear force values to find first. Shear force point at each every point we need to draw the shear force diagram. Here the shear force diagram is given. This is to be drawn after calculating the shear force at all points A, C, B. These are the 3 points we are having. At all 3 points we have to find out. Before seeing this one, the support reaction, we have to see the which one is positive, which one is the negative sign conversion to draw the shear force values. So shear force we can have left up is positive, right down is negative. From the reference point, let's take here B is there. From the B can take a right reference or left reference. So right reference means you can have right down is positive, left is or up is positive. Like that, you have to consider the values for positive sign convention as well as the negative sign convention. Here, shear force point the point to the left to its left, that is shear force at A point. From the point A, here we are considering. So from the left side, if you are considering, we don't have any load at all here. So you just from the reference point find the left side alone. You can just see that we have one. There is no load at all. So shear force at this point equal to 0. And to the right side, if you take the reference point at right, then consider the left side. Okay. Now what are the forces are available? So since you are taking the right side, that is reference point. You will have another one is one and only is that RA. RA if you are having, so this is 3.5 kilonewton. The value is 3.5 kilonewton, but whether it is up or down. So left, you are considering from the reference point. I am considering the left side. So left up is positive 3.5 kilonewton. As well as you can go for the C point. So from C point, reference point you take this one here left side and consider the left side alone. Okay. So since very no load are there except this RA, so the RA is the shear force at this point. So it is also positive left up. Then you go for this side. In this side you consider the two load. That means two sides. That means 2 kilonewton as well as the 3.5 kilonewton. Two loads are there from this point reference point. So you will have 2 plus 3.5 minus 2, that is equal to 1.5 kilonewton. Here it is here. Like that, you can go for the shear force at B point. Here also you have these two loads are there. So since it is 3.5 minus 2, it's also 1.5. So finally I am getting the values of each and every point. So shear force at, let's consider from here. So shear force at B is equal to 0. That means at this left side you have a 1.5 kilonewton, and here also 1.5 kilonewton. Here the value is 3.5 kilonewton, and here it is 3.5 kilonewton. Like that, we can mark the values of at each and every point of the shear force values. Then how to draw the shear force diagram? The shear force diagram can be drawn. So here you will in the region, you just have a region here. So no loads are there. So you have a horizontal variation. It means horizontal line you have, and at the particular point you have a load. So there will be an increment, whether it may be a downward decrement or upward increment. Since here from 1.5 and at this point it is going to be 3.5. So from 1.5 to 3.5 there is a increment. So it will be towards upward side. Then from C to A, so here also there is no load. The same value 3.5 will be existing here. So it will be a horizontal line. Then you will close it. So like that you can draw the shear force diagram, SFD. Then we can move on to the bending moment. Bending moment, how can we find out the bending moment? Generally we should have a mathematical expression called force into perpendicular distance, that is equal to bending moment. And bending moment sign convention how we can take. So from the reference point, so this is the sagging effect, positive sagging bending moment. This is the negative bending moment. So in the left side we will have the upward force, right side is the downward force. So this upward force always creating the positive bending moment diagram. Whether you can see the reference point from left side or right side, wherever you are taking, the upward force will create the positive bending moment. That's the point here. So like that we can have from the point B and point C and point A. Like that we can move on that. At point B, here from the reference point, you should not have any distance. So you have 1.5 kilometer at this point, but there is no perpendicular distance since it is acting at the point B itself. So 1.5 into 0, 0 kilometer meter. That is the value here. Then what about the C point? So C point means you can consider 1.5 kilonewton into perpendicular distance will be equal to 0.5 meter. And this 2 kilometer is coming into picture, but there is no perpendicular distance. You just ignore it. So the value is equal to minus 0.75 kilonewton meter. Since it is downward force creates the negative bending moment. Then you can move on to the point A. So at point A, what is the bending moment? At point A, you consider from this 1.5 to here 1.5. Then 2 into 1 meter here. So both are negative values. So minus 1.5 into 1.5 minus 2 into 1. That is equal to minus 4.25 kilonewton meter. This is the bending moment diagram for bending moment values at point A and C as well as B. So these are the 3 points available here. Kindly, I am just placing this is the zero bending moment line horizontally. From that upward positive values goes upward. That means upper side of the zero bending moment line. and the negative signs, negative values are below the zero bending moment line. Like that, I have to draw here. At point B it is 0, and at point C it is minus 0.05, so it will be drawn negativity in the downward direction. That means below the zero bending moment line, and this is minus 4.25. Now, how can we can place the marking? Then how can we draw? Since there is no load at all, we just make a direct line. That means a straight line or inclined line, direct joining of 2 points. That is the concept to draw the bending moment diagram whenever there is no loads are available in between the region, as well as from C to D, from C to A. Here C to A also there is no loads are there, so it is a direct joining of 2 points. So you will have a complete bending diagram we have seen here. So that's all about bending moment calculation, and how to find the shear force diagram versus the bending moment diagram. I will see you in the next class in the different types of beams to find the shear force values, bending moment values, and how to do the shear force and the bending moment diagrams. Thank you.